Hey everyone, and welcome to today's Explainer. I am absolutely thrilled to guide you through this journey. Today we're going to be decoding the digital web, totally breaking down the seemingly invisible infrastructure that powers our entire modern world. We're going to scale our perspective all the way from the local routers sitting in our living rooms up to the massive global space satellites orbiting the Earth right now. It is a wildly fascinating topic, and I promise you, by the end of this, you're going to see the digital world around you in a completely different light. Okay, let's dive into this. Here is our roadmap for today. First, the network starting line. Second, LAN, your local bubble. Third, MAN, expanding to the city. Fourth, WAN, connecting the world. Fifth, LAN versus WAN, the showdown. And finally, number 6, VPN, securing your connection. All right, section 1, the network starting line. Before we can talk about global connectivity, we really need to understand the fundamental building blocks of how our physical devices actually talk to each other in the first place. Take a quick second and look at the exact device you're using to watch this explainer right now. Seriously, look at it, because whether it's a mobile phone, a laptop, or a desktop, you are actively participating in a computer network this very second. A network is simply a system connecting two or more devices, from mobile phones all the way up to massive servers, so they can share and transmit information. And those connections? They can be physical, like copper wires and fiber optic cables, or completely wireless. The real beauty is in that connection, allowing your single device to tap into servers holding vast amounts of shared information. Now, when you look at how all these servers, smartphones, and computers actually route and interlock, it can look a lot like a giant puzzle, right? Kind of like a bowl of technological alphabet soup. It's totally fine if it feels a little overwhelming at first glance, but stick with me because we are going to demystify this chaos step by step. It's actually a beautifully logical system once you see how all the pieces fit together. Moving on to section 2, LAN, your local bubble. So zooming all the way into our most intimate network type, the local area network, or LAN. Now, what's really interesting about this slide is how all of its advantages stem from simply being small. This is the network connecting computers within a very small geographic area, like the room you're in right now, your office building, or a university campus. Because it's localized, it really doesn't cost a lot of money to set up. You get an incredibly high rate of data transfer, meaning it is super fast, and it's remarkably simple to operate and control. Your data is saved centrally, and if you buy a new laptop, adding it to the network is practically effortless. Basically, keeping things local keeps them fast and cheap. But, as we're going to see throughout this explainer, networking is literally all about trade-offs. The disadvantages of a LAN are directly tied to that cozy, tight-knit structure. Yes, it's fast, but it covers a highly limited geographic area. And because all these devices are basically holding hands, it is significantly easier for a virus to spread rapidly across the network. If your central device fails, boom, the whole local network crashes right along with it. And ironically, keeping everything local and fast might actually require some extremely high-maintenance physical cabling snaked through your walls. To make this local bubble function, a LAN relies on hardware that is probably very familiar to you. We're talking about the network interface cards inside your machines, wireless cards, and all those switches, bridges, and routers that are likely sitting on a desk or tucked in a closet right near you. They really are the everyday, unsung heroes of your local connectivity. Section 3. MAN, expanding to the city. Okay, let's scale things up from the building level to the entire city level. The Metropolitan Area Network, or MAN, bridges the gap, effectively connecting multiple LANs together across a town or a city. It honestly sits right in the sweet spot of our networking scale. It's obviously larger than a LAN, but it remains less expensive and uses way fewer resources to set up than a massive global network. A classic example of a MAN is your local television cable network. It efficiently balances geographical scale and cost while still offering you greater security than the completely open World Wide Web. However, that trade-off motif continues. Expanding your network to the size of a whole city introduces some real friction. For starters, your data rate slows down compared to that lightning-fast local network. Securing the whole system against hackers? Yeah, that becomes a lot more challenging because your perimeter is now citywide. Physically managing this extensive network with all the extra cable and infrastructure required turns into a major logistical headache. And naturally, it ends up being more expensive than a simple LAN. Let's see how this expands our hardware requirements. Expanding geographically means we have to shift away from just relying on simple local switches. To connect across a whole city, a MAN utilizes peripheral devices, modems, extensive wire and cable, and it even taps into broader infrastructure like phone connections and radio waves. We're literally leveraging the city's environment to carry our data. All right, Section 4, WAN, connecting the world. Time for the ultimate zoom out, scaling way beyond city limits. The wide area network is what happens when we span massive geographical regions, entirely separate countries, and fundamentally form what we know as the internet itself. The sheer magic of the WAN cannot be overstated. It stitches together all those smaller LANs and MANs globally. The primary advantage here is absolute, borderless communication. A device in one city, say an office in Lahore, can instantly connect and share data with an office in Faisalabad or Tokyo or New York, all through a centralized IT infrastructure. It literally shrinks the globe. But bringing the entire globe together definitely comes at a steep price. The speeds are inherently slower than your local LAN because, well, the data is traveling massive distances. The setup costs are absolutely astronomical. And think about the maintenance for a second. We all know how wildly frustrating it is to untangle the cables behind our TVs. Imagine untangling the digital traffic of the entire planet. It is incredibly complex and requires a heavy reliance on specialized, high-performance devices just to keep the whole thing from collapsing. To achieve this crazy global reach, our hardware evolution has to escalate dramatically. We aren't just using routers and basic cables anymore. A WAN relies on the public switched telephone network and, amazingly, satellite links. That's right, we are literally bouncing data off communication satellites in outer space just to keep the wide area network running smoothly. No way, right? Section 5. LAN versus WAN, the showdown. So the crucial point is really understanding how these two extremes compare head-to-head. The core rule of networking is that you are constantly trading speed and low cost for vast geographical distance. Just look at the breakdown. The LAN operates over a small area, it's privately owned, inexpensive, and features lightning-fast data transfer. The WAN is the complete inverse. It covers great distances worldwide and can be publicly owned, but as a result, it's far more expensive and suffers from significantly slower data transmission speeds. You can have speed and control locally, or you can have global reach, but you can pretty much never have both without making a compromise. And that brings us to Section 6, VPN, securing your connection. Now, for a really important final plot twist. We've just learned that to reach the world, our data has to travel across these massive, interconnected, and highly public wide area networks. So how on earth do we keep our personal sensitive data safe out there? The answer is the Virtual Private Network, or VPN. Think of a VPN as your ultimate undercover tool. By definition, it creates a secured connection over the public internet from your device to a network. This is the exact technology that allows users to conduct work remotely. It safely navigates you through the massive, vulnerable WAN by creating a private little tunnel just for your data. And this brilliantly illustrates exactly how that undercover tool works, down to 3 precise steps. Step 1, the VPN establishes that secured connection right over the wild terrain of the internet. Step 2, it encrypts your traffic to ensure that sensitive data is safely transmitted. And step 3, through that encryption, it actively prevents unauthorized people, the hackers and snoops lurking on the public web, from interfering with or reading your traffic. It essentially gives you the privacy of a LAN while you are busy traversing a massive WAN. We've zoomed from the wires in our living rooms all the way out to the satellites in our sky, revealing the incredible, yet somewhat vulnerable infrastructure that connects our lives. But it leaves us with a critical thought to ponder. With your data traveling across all these vast networks, from your local bubble through citywide grids and out to global satellites, who is really watching your network right now? Are you truly protected on the global grid? It is absolutely a question worth asking every single time you log on. Thank you so much for joining me on this explainer, and keep exploring.